Welcome everyone. My name is Peter Shipp. I'm principal of Zio Group. We're a local technology integrator here in Central Florida. We are about 45 people. We do work in about 4 states, all the way up the East Coast. We've got a majority of our operations is here in Central Florida. We do a lot of projects in the Atlanta, Georgia area, and then we've got a fairly sizable operation up in the New England area. So what we're going to talk about today is LED and lighting control application considerations. So if you have any interest or want to learn a little bit more about lighting control and how it relates to LED lighting, you are in the right place. This is a newly updated presentation, and so hopefully there'll be some good nuggets in here. I may stumble over a few things because I've only done it a few times, but I've been doing this stuff for 20 years. So feel free to stop me, ask a question. I don't have a script that I'm following or anything. I'm going to just go through what I hope will be some valuable information about lighting control and LEDs, and ask questions. I don't mind at all, and we'll leave time at the end for follow-up. It won't take me the whole hour to go through everything. This course is registered with AIA CES, so if you are eligible to get CEUs, you will get credit for those. And so what we're going to talk about is, like I mentioned, LEDs and their application with lighting control. LED lighting technology has changed rapidly since it came out. The best analogy I can give you is just like your phone there's a new phone every year. There was a new computer every year. Computer rate of advancement has slowed down. Phones are starting to do the same. Well, the LED innovation curve started with lots of change, and now that has somewhat started to slow down, but we're still very early on in that progress. We're going to talk a lot about controls and how they relate to LED, because the way we used to control lights and the way that LEDs should be controlled are very, very different. And then driving factors in going forward, what you're going to be seeing, which you're probably not really seeing right now with lighting control. And this is basically the same thing. They make you do these learning objectives and what you're going to learn and everything. So most common design considerations, what's driving LED adoption, and one important one, interesting, is where we came from, how we got where we are, and where we're going. So the first thing I always think is most important when we talk about controls, which is really a small segment of both electrical, but then also the interiors and design and spaces, but then also exteriors of buildings, is who is involved in everything it takes to get lighting and controls into a building or a space. And you have all these different players, right? So many architects. Is anybody not an architect in the room? What are the non-architects, other than Zio people that are filling the room? What do you do? Interior design. Awesome, perfect. So whether it's architecture or interior design, right, you've got a vision for the space, for the building, for what it's going to look like, and lighting is a big part of that. There are a whole bunch of people involved in the value chain to go from that vision all the way through to completion and realization, right, just like all the different trades. But even within lighting, you have, of course, what we divide the most important part at the beginning and the end users, right? What does the end user want? And what does the end user get? And in a lot of projects, you have capital money that's making the decisions on what you're going to get. And then you have the operational people that are like, well, that's what I want, right? And making sure those two are aligned is important. And then, of course, there likely is a lighting designer involved in many cases, a manufacturer's rep that's trying to get their product specified, electrical contractor that's maybe carrying the actual value of the equipment and installation. When you get further down the line, there's commissioning agents. There's generally how this ends up going through a contractor. There's lots of people involved. So how do those people relate to each other? So it kind of falls down this way, kind of the waterfall effect of, the architect, for example. Generally, if you've got a big project, you're going to bring in a lighting consultant, and maybe that's part of the scope of electrical engineer, or maybe that's just part of the electrical engineer scope. And they're going to rely oftentimes on a manufacturer's rep. Just so happens we have one of those sitting in the room. This is Tony, who works for Core Essential, who's the Lutron rep, one of the manufacturers we work with. And so he's out there trying to get you guys and engineers to use their product, right? And that all flows around and through, and then eventually gets to a distributor, an electrical contractor, and then ultimately to the end user. Well, there's a lot of things, moving parts and pieces, that could potentially go wrong in this equation. And that's separate from the technology and things that could go wrong in the technology. So who are the decision makers typically, right? So you can kind of remove a lot of the players, and oftentimes the owner, the architect, and consultants over here are the ones that are really doing, through the design, that iterative process of making decisions, right? But usually what we find, so we're an integrator, is we find that there's a missing link. In other words, these decisions sometimes can happen in a vacuum, especially the further down the chain you get. And as technology evolves, and as the needs of the end user evolve, and making sure there's alignment between the two, how do you make sure that that happens appropriately? And so there's companies like us that are integrators that help to provide services and solutions throughout the cycle of design, all the way from the beginning in needs analysis and budgeting, helping lighting designers and engineers understand the complexity of the technology, and then coordinating that through the value chain all the way from the beginning to the end. So a very important part. So the message here is, whenever you have a lighting project that is of any, I don't even want to say size, but complexity, right, where there's going to be lighting controls, which is the bulk of what we're going to talk about, having an integrator involved in that value chain to help make sure that all the right pieces are coordinated so that the lighting design is properly coordinated with the engineer, so that you get controls that actually work, that realize the promise of what's talked about in the beginning actually carries through to the end. What an integrator is going to do is stay with that project from as early as possible, right? Ideally, an integrator, we want to be involved here, but sometimes we don't get involved until here. A lot of times engineers will call us and say, hey, we've got this big project that's got all these controls on it. We need somebody to help us with that. And by the way, we don't work for just one manufacturer or work for any manufacturers, but we don't just use one manufacturer's product. The reason we're called an integrator is because we integrate different solutions. And so companies like us will really look at the needs of the project and recommend the best solution. And then carry that solution all the way through. So our scope is typically not isolated to any one area of the project like everyone else typically is. And we're very focused on that subject of controls.
Are you either missing a link or are you the most important link? There's nothing connecting to the programmer, and I would have almost put an integrator in as the programmer, because if the programmer is not executing what the owner wants, then he's still not getting what he wants.
So
the programmer is the one that tinkers with all of the...
100% right. So I didn't show a connection there, but typically the integrator is the programmer. Now,
That's what I thought. Okay.
we're not typically going to be the commissioning agent, because when there's a commissioning agent, you got it, right? So for anybody who doesn't know, commissioning agent, if there's any type of certification, must be separated.
You are the programmer.
Typically, yes. Now, as an integrator, we're interesting, this is not just us, anybody who does this. In many cases, and we're like this, we can't necessarily be involved in just like the commissioning agent can't. So sometimes we'll get hired just to help write specifications, do needs analysis, and do budgeting. And then in other cases, we don't get pulled in until later on in the project. So they don't necessarily have to do the whole thing. Obviously, that's ideal, but not required. But a lot of the value comes in here, where in a typical solution, so when a manufacturer, control manufacturer like Lutron or ETC or Acuity or all the, there's tons of them out there, when they get specified by an engineer or by a rep, usually what gets included in that is factory services. But when that factory services guy shows up to do the programming, he more than likely wasn't involved in all this. And the people doing the actual shop drawings and the submittals that are being approved by the engineer, they're doing that in a lot of times somewhat of a vacuum. And even if they're not doing it in a vacuum, they are doing so many projects, usually the entire country or Southeast or the entire state of Florida. They can't possibly have an intimate knowledge of the specific project. And that's where the integrator's value is really understanding the project. So when you get here, it's, oh, I understand what we were trying to accomplish here and what they need to accomplish here. So great question. So let's talk a little bit about the technology. And if I go too fast or I talk about anything that doesn't make sense, either stop me or feel free to ask at the end, because this does get a little into electronics and kind of geeky. But I enjoy this stuff, so I'm happy to answer any questions. So let's look, I think to understand where we're going, it's helpful to understand where we've been with lighting And lighting really started with the incandescent light bulb 150 years ago. And that has now evolved to what we all probably know at this point. You can't walk down any store that has light bulbs and not find an LED. This is an A19 typically, screw-in lamp. This would be considered an A19. And they evolved, right? So you went from incandescent. You can still get halogen versions. Those are the, still allowable, somewhat energy efficient that aren't LED. Compact fluorescents are pretty much gone. And what's left are LED. Well, what this basically did is we went from a tungsten filament that was basically created light by creating resistance, right, and created that warm glow, to silicon chips with phosphors in them that are very, very low voltage DC, direct current, like how your car works, battery, versus 120 volts or 277 volts AC, alternating current. So not only is the way we make the light different, the way we power the device that makes the light is very different, right? So there's no electronics in here, there's no conversion. It's literally the hot and the neutral, and they arc, and they create resistance, and you get light. Here, these little chips that run at a maximum of 5 volts DC need a power supply to make them work. So the early days of LED and still today, when you see flickering, the flickering is not the LEDs, it's actually the power supply that is not happy with converting AC to DC. And we'll talk a little bit about that. So that's retrofit lamps, right? Screw in A19s and PAR 30s, PAR 36s, et cetera. Now what's happened is we've got, of course, LED purpose-built fixtures, right? So you're doing a new product, you're specifying downlights. You're typically not going to put in a can that has a screw-in lamp. It's going to be integrated. That started off with compact fluorescent. Again, can't really get those today. So now you see integrated LED fixtures. Those have a power supply like this, except it's separate. So it's easily replaced. And then you have what we call a light engine that's built in. Those have been around for a while, and they've evolved, and they've gotten much, much better. But most of them today, unless you make an effort, which we'll talk about, to specify correctly, are intended to be used with the same 120-volt dimming that these lamps used. So we basically took a square peg and put it in a round hole because that's what we've always had. So let's talk a little bit about how do we control lighting, right? So historically, we have all these different things. Some of these have been around for 100 years, and some of them are relatively new. The ones in bold you might recognize. So 0 to 10 is very common. That's a way to control lighting. It really started with fluorescent, but has definitely carried its way over into LED. Phase dimming, which encompasses forward and reverse phase, or ELV dimming, MLV dimming. Does any of those things sound familiar? A lot of them are overlap. So for example, ELV is really the same as reverse phase. MLV is the same as forward phase. There's a whole bunch of terms. Then we get into things like warm dim or tunable white, circadian rhythm, newer buzzwords that have come about because of LEDs and the things that we can do with LEDs that we couldn't do with fluorescent or incandescent. And then some really cool technology that really relates to smart buildings and building automation that is evolving and coming down the line because of the intelligence that's now in the ceiling, right? Lighting is everywhere that people are. And so where people are is usually where we want to have technology, right? So things like wireless power, occupancy sensing, oxygen sensing, asset tracking, right? The ability to have, let's say, for example, in a hospital, all the equipment that's in a hospital, asset tags, right? Or just computers or mobile devices, anything that you want to track. And the lighting actually provides that GPS communication. So there's all sorts of cool things coming with regards to control. So then what are the types of controls that you'll encounter, right? And there's not a lot new here, but it's helpful to understand how this relates going forward to new technologies and, of course, control of LEDs. So typical panel-based. So you have an equipment closet that has these big panels. They generate lots of heat. They take up lots of space. They make noise sometimes, clicking and buzzing. Then you have more distributed room-based controls, right? So we still have lighting control. It's not just a switch on the wall, but that need usually comes about because there's an occupancy sensor or you have switched outlets to meet energy code requirements. And those could be standalone, or they might be interconnected together to a larger building management system, but typically these are standalone systems. These are very, very common. If you walk into a room with an occupancy sensor or an open office space with lots of lighting where the lights turn on and off automatically, there's usually not a lot of sophistication behind them, but there is some type of controls. And in this example, the controls, the neon orange here is actually low voltage control wiring that links everything together. Then wireless controls have become more popular. Really to the point now where with distributed controls, we really see a move from the same types of architecture except without having to run the control wire. So electrical contractors love this because they do all their normal wiring for the most part. They put in their little control devices or use integrated fixtures where the controls are built in and everything communicates together wirelessly. And then the last application, which we call enterprise or network-based control, that's really where integrators are involved, where you have big projects and you have lots of rooms and lots of different types of lighting, where you might still need panelized lighting for sconces and chandeliers, more decorative architectural lighting, but then you would also have more utilitarian troffers and downlights that can use more distributed controls. And network systems bring all that together. So with panel-based controls, the biggest downside to them is circuit level control only. So you're really taking what was a switch or a dimmer on the wall and you're moving it to a closet. And the advantage of doing that is you remove the wall clutter, you provide centralized control, you provide scene control. Now you have a keypad on the wall that describes what the preset does as opposed to somebody having to go and manually adjust. They take up a lot of space. Very limited LED compatibility because they're designed to work with traditional load types. When there is a failure, you could potentially lose many, if not all, the loads in the panel. It's rare to happen, but there is that possibility, single point of failure. You're limited in system visibility from a maintenance and technology standpoint, right from a facilities management, because you really can't see the status of the connected load. You know the panel's there. You know what each of the panel says, oh, circuit number 12, which is the meeting room downlights, is at 25%. But you don't actually know that the lights are on or they're at 25% because there's no connection to the fixtures. And you have somewhat limited integration capability, integration with third-party systems like AV, meeting room AV systems, building management systems. The other thing to be aware of with panel-based controls is they were designed, as I mentioned, for traditional lighting. And with the new types of lighting we talked about, while you can order them from the manufacturer to be compatible in many cases with traditional panels that are what we call phase control, it's really not the way that these are designed to be controlled. Again, going back to the fact that these are LED is a DC-based device. There's technology and electronics in these, and there are much, much better ways, more cost-effective ways, more space-saving ways, and more solution-driven features that make the building more valuable and make the controls more usable. And we'll talk about that in a second. So, of course, distributed room-based controls, as we talked about. Now you're at the individual fixture level. You have much less equipment because there's no panels with the remote dimming. There's not a lot of infrastructure that's required because the devices are at the fixture. It supports both what we'll call analog and digital dimming. So one of the downsides to this type of architecture is you're typically not going to have architectural and decorative fixtures. You're typically not going to have a chandelier or a sconce or any type of fixture like that. It's going to be very utilitarian fixtures like what you see in this space. And therefore, your dimming control is limited to low voltage types of dimming. The failure of the system is is because it's distributed. There's really very few single points of failure, which is a positive. Sometimes they have what we call front-end controls to them, the ability to centralize and manage scene presets, what happens when there's occupancy, time clocks, turning the lights on and off automatically, things like that. Integration capabilities are usually fairly limited or non-existent. Wireless lighting control, pretty much the same thing. The biggest advantage to this over the prior is that control wire goes away and the communications for control are wireless. And with this, what we are seeing more and more of is fixture manufacturers building the controls into the fixture so that when you order them, you say, hey, I want to use this type of control protocol, and when the electrician installs it, all he has to do is get power to the fixture, which greatly simplifies electrical and saves money. And then when programming is done and commissioning, basically come through, fixtures flash, we identify them, we set presets, and we're done. So this is just now starting to become popular, and as more and more manufacturers integrate those controls, it will become much easier and more cost savings on the installation side. And then the last one, of course, is network-based lighting control. And the key message here with this is it really encompasses everything you just saw, right? Panelized, distributed, and wireless, all into one cohesive system. So if you have a big project and it has the need for, let's just say open office space, that's basic, right? That would be a distributed system. And there are training rooms that would need more control. For example, there are air walls, there's lighting for a stage, it's got to connect to the AV control system, and then there's also executive spaces, lounges, areas that would have decorative controls. A system like this will bring all of those together and give facility managers the ability to basically be able to look into and see and maintain and support the entire system as really one cohesive system as opposed to these separate islands. These systems are often considered complex and expensive, and they can be, but if well designed and well coordinated with the lighting design and the electrical system, much of the complexity can be removed, and the value really comes down to long-term operation and maintenance. And like I said, this is a lot of what I guess you could say I have a biased opinion on this one, because as an integrator, these are the types of systems where companies like us really have value, where the need to bring together lighting controls in a large building are valuable and important. So in this market, for example, a lot of resort hotels and convention facilities use these types of systems to manage the lighting in all their spaces, all the way into guest room corridors and actual individual guest rooms, integration with the property management system. There's lots of advantages to having systems like this. And as we get more and more into digital controls, which is the last big topic we'll talk about, the interfacing to these systems ends up becoming a very small little box, and nothing really that complicated as long as the right fixtures are selected. So what are some design considerations when picking lighting, right? So obviously you guys aren't lighting designers, but this is something to be aware of when you've got a project that's got a lot of lighting, and the types of things we've talked about where controls are involved. Be aware of these considerations, right? So has anybody ever looked at a fixture cut sheet, right? So this might look familiar. This is a pretty typical looking cut sheet. The top half is really the light characteristics, right? What's the form factor? How big is it? What color temperature do we get out of the fixture? How much light do we get out of the fixture? What type of reflector? All the physical, mechanical, and optical characteristics are up here. Then the bottom half of this cut sheet really gets down to things electrical and control, right? So what type of driver? So there's all these different options, different voltages, and then they give you more options, and then they give you what they call control options, which are just more options that relate to drivers, right? And it can get really complicated really fast. Engineers, or I'll just say lighting designers, are very comfortable up here. It's hit or miss down here. Usually they're going to go with what they're comfortable with, which is 0 to 10. It's very commonly, I hear this all the time, lighting designers will say, and even engineers, oh, 0 to 10 is the standard. When we go through and we do a spec, we train our guys that you just pick 0 to 10, and maybe like, for example, this one you have 0 to 10, and then you have another one that's 0 to 10, 1% dimming. Ooh, I've heard about this 1% dimming thing. I want that, right? So they'll go, I'm going to upgrade the project, and we're going to do 0 to 10. And then oftentimes, once they get to the options part, we're just not going to specify anything. That's for the engineer and the technical people to do. And then the engineer comes along, and he looks at it, and he goes, okay, yeah, 0 to 10. They probably might say the same thing. Oh, voltage, yes, that's what we need to know, right? So they're going to look at voltage, and they're going to look at the lumen package to see how much current it draws, and they're going to do their power calculations, and they're done. And that's usually it. The trick is, what are all the other controls options, right? So in this one, we have fixed on-off. As I mentioned, we have 0 to 10. Then we have wired digital dimming, which we'll talk about in a minute. Then we have wired dolly dimming, so different type. Both are considered digital. This one, actually, we don't say the name, but it's Lutron's version of dolly, what they call ecosystem. Then over in our options, if you didn't choose one of these, or to make it more confusing on you, there's a wireless control option. Then there's another wireless control option that adds occupancy and daylight sensing, right? So this fixture has that sensor built in. And then there's another one for CommScope system. Yes, CommScope, the cabling company, has a lighting control system. And then there's another one for Lutron Vive, their wireless system, right? So this manufacturer's been progressive and saying, hey, we want to support these wireless options, but you have to know which one you're going to use. Question?
The industry, a lot of times when things are new like this, or new or open architecture is not forced or is it resisted? It's really up to everyone in this room, ultimately, and the design community to insist and ask for open and standards. Unfortunately, right now, I have this term that I use called the United States of Proprietary. And unfortunately, manufacturers have a vested interest not to be open and standardized because they want to get you in on their system, right? So we have, Tony knows me. I'm not going to be shy about it. Manufacturers like Lutron want to sell you their solutions, right? So when I talked about here earlier, digital dimming, what they call ecosystem, they took basically the Dolly standard, which is a European standard, digital addressable lighting interface, it's been around for 30 years, and they said, oh no, we can't support this proprietary standard, we have to call it something else. So Lutron called it ecosystem. Now having said that, there are benefits to a manufacturer doing that because they take a loosely defined open standard and they lock it down so that it's very predictable, so that you don't necessarily need an integrator to make it work or somebody that understands the controls. But the reality is their main goal is they want to keep you in their ecosystem, if you will. And we still see that happening today with, that was 15, 20 years ago. With ecosystem, we still see that with all the new wireless technologies that are coming down the line.
To your point, the answer he's given today will be vastly different than the answer he gives next year. It's going to be vastly different than the answer he gives 5 years from now. So what you're saying is really coming.
Yep. And that's our hope, our truly as an integrator, that at the end of the day, we just want to see solutions that work, right? Our goal is simplicity, reliability, and low maintenance, right? And so to accomplish that, the ability to have open standards that allow the thousands of manufacturers that make luminaires to be able to support the dozens of control platforms that are available, where everyone in the value chain can say, you know what, I don't have to worry about what fixture I choose because it will be compatible as long as I pick one of these standards, is the goal long term. We're seeing this in Europe now. There are several standards that are really enforced by the EU that had actually started years ago with wired standards. And the United States, there's really no governing body that has the ability to enforce things like that. And so it remains to be seen what happens in the U.S. Again, that's why I say the United States is proprietary. But
we're at the beginning of the Wild Wild West right now.
Yep. But at the end of the day, the important factor is to really just be aware that this exists and know that you can get to a good outcome. It just requires a little more effort, and it doesn't happen by default, and it certainly doesn't happen by accident. So what is the most common control method used today? I think I gave it away. Anybody remember? 0 to 10. Yep. And the key thing to understand there is 0 to 10, number 1 is analog, and number 2 is not new. It's been around for, 50 years. It's a very common way of communicating different types of systems for logic communications. But it's analog, and actually we'll talk about that here in just a minute. So bringing you back to this chart, we've highlighted, as I mentioned before, the two most important people in the equation, right? The owner in the beginning, they're the ones that generally make the design decisions and have the money, and then the end user. And in many projects, especially large projects, these two are the same, but they're not the same. Well, these might be the same, but what they're really telling you is different, right? Same, but different. And in many cases, these are not the same, right? So we see this all the time.
A good example here in Central Florida, if anybody's ever worked for Disney, right? So you have the design people that say, this is what we're going to do. And then we go through and we do the project and we get to the end and the operations guys show up because, you know, we're opening in 2 weeks and we got to make all this work. And they're like, no, we don't want to do this. We need to do this, right? And then this ensues. And then all the contractors and designers and everybody are in the middle going, oh my gosh, how do we figure all this out, right? And then they have to politically do their thing. So what's really important is to make sure that these two things are aligned. So when it comes back to this, right, and from the design and specification side, what's the most important thing, right? I showed you a whole bunch of different options here, right? And I don't expect you to take that back and start asking clients, you know, well, what type of control system do you want to use, right? But the really big question, these two things up here, if you can see them, very simple questions. When you talk about lighting, is there a preferred control system? Do you have something that you worked with? And if so, is there a system you prefer not to work with, right? Have you had a bad experience? Or conversely, is there a system that you've had good experience with and you want to work with? Just simply asking that question early and bring up that conversation and communicating that to the lighting designer and to the engineer and hopefully to a controls consultant, an integrator, can help to start that communication, which then, when you get to the stage of actually doing the design and these decisions are being made, you have that guidance that can help eliminate very simple answers to these questions will narrow down 20 options down to maybe 2 or 3 options. And usually the lighting designer and the controls guys and the engineer can figure all that out from there. So that's the most important part. So then we talk about types of controls. So this, and I'm happy to send this, by the way, afterwards. Leave me your card and we can send you this presentation. These are today the most common types of controls. So we've broken it into 3 categories. You heard about 0 to 10, what we call analog low voltage, and then phase control, which has been around the longest, right? That's a standard wall box dimmer or a big dimming panel in a closet. We call that analog because there's really no communication between the controller and the fixture. It's just varying a voltage to get an outcome, a dimming level basically. And by the way, you'll see that even used with tunable white fixtures where it offers the ability to vary the color temperature and the intensity together. There's a couple of manufacturers that make nice product that does that. But to be compatible, they make a version that literally has 2 0 to 10 volt connections on it. So now you have to run not 1 but 2 low voltage control wires together with power. And by the way, the power usually has to be switched. So now you still need a panel in the wall to switch the power and then 2 low voltage control wires to adjust intensity and color temperature. Don't do it, right? But that's usually, 0 to 10, that's the standard, we're going to pick that. When we get to digital, Dolly, as I mentioned, DMX, probably the most popular in the United States. You really don't see it anywhere else, Europe or Asia, but in the United States, DMX for architectural lighting. It's really a show lighting theatrical standard. It stands for digital multiplex. A relatively high speed, used to be high speed. Today's high speed, gigabit and Ethernet and everything, it's actually very slow, but relatively speaking, it's fairly high speed. If you go to any type of concert, or anything where you see color changing lighting, moving lighting, gobos, effects, it's using DMX. So it's very common. We now see it as the most popular option in terms of digital controls, even in architectural systems. So that's a big thing that an integrator is going to be well versed on is how do I blend together architectural systems and theatrical entertainment systems, what we call architainment, right? So being able to bring those two together to have a facility-driven system that's going to be maintained by maintenance guys, but that controls theatrical and show lighting systems that typically you need training on. And when we send our guys to factory training for these types of systems, they're there for weeks over the course of maybe a year, a couple different trainings, and they work on it constantly because they can be complex systems. Power line. Not all that common, but is around. There are some specific manufacturers that will use power line as a way to communicate to their fixtures digitally, but without having to run additional control wires. Very, very proprietary. Really good solution for outdoor applications where you don't want to run control wires, and also retrofit applications where you can't run control wires. BackNet is a control interface. Anybody heard of BackNet before? Cool. So BackNet is really how we talked. That is an open standard. It's actually an ASHRAE standard, American Society of Heating, Refrigeration, Air Conditioning Engineers, if I got that right. It's the HVAC guys, right? So that's their standard, and thankfully it is pretty much a well-adopted open standard because that industry said, hey, we need this, and the industry came together. The reality is you still have the Johnson Controls, the Trains, and Siemens that really don't want to support this, but they all do. And that is a really big component when it comes to lighting control for integrating the lighting system into the building management system. And what ultimately where this is going, what we see is as the buildings go from just having automation systems to really being intelligent and being able to make decisions about how to make the building most efficient and how to adapt to the users in real time, they essentially become smart buildings, right? So artificial intelligence will really take over the building as we get into the next 10, 20 years, and things like this will be the way that everything talks together.
Dangerous word though if not used correctly. So you can equate that BackNet word to a mechanic, and you can say, hey, this mechanic is qualified only to open the hood. That's all he can do. And this other mechanic is qualified to open the hood, take your engine out, take the engine apart, reassemble it. So BackNet by nature, someone saying I'm BackNet compliant is one thing. Someone saying I'm BackNet native, that means everything that I have in my system is exposed to that BackNet integrator, which is really important to gentlemen like him and the building automation people. So be careful if you have that requirement from an owner that you understand that that word can be dangerous, double-edged sword.
Yep, yep. And this is another one where we don't expect you to ask a client, do you need BackNet? It's a matter of asking that question about controls, and maybe if the answer is yes, and it's a big building and they have a building management system, hey, do we need to make the building management system talk to the lighting system? I do another presentation very commonly about just integrated technology, whether it's AV systems and lighting systems, because we do both, and how that works in the whole building and design process. And usually in that presentation I say multiple times, I don't expect you to walk away with all the information and being armed to remember it and use it all, but I do want you to have one simple key piece of information, and that is to know when to bring up, hey, this is something that's out there, let's be aware of it, let's ask the question, and get the conversation started. And that's very much the case here with something like BackNet.
Well, to your point, really what's happening is the old school way was to design a lighting system and then pick a control system. Currently what we're seeing people do is we're seeing people pick the control system because an owner has a set of needs, and then the lighting system is selected to support that. Yep. So it's been a little bit of a role reversal.
Yep, yep. And a lot of people aren't used to doing that. Yep. So then wireless is really where the future of these systems are. So kind of run through quick. You may have heard of some of these. Zigbee is a standard that is very much like Wi-Fi. Z-Wave is very popular in residential. We really aren't seeing it in commercial buildings, and we probably won't. Bluetooth, right? Everybody's probably heard of Bluetooth, right? The way your headset connects wirelessly to your car or to your earpiece. What's interesting about Bluetooth is there is a variation of what's used with your phone for short communications that allows a mesh communication there are already systems out there that all the lighting in a building communicates over Bluetooth. Very interesting going forward. Same thing with Zigbee. Zigbee and Bluetooth are really the two, when we talk about wireless building automation systems and lighting controls, are really the two most likely to long-term be players in the market. Wi-Fi, really, it's out there. You can get lighting devices that work with Wi-Fi. It's really not scalable. And there's a lot of overlap and unnecessary need to make a light fixture talk via Wi-Fi. Wi-Fi is intended to handle lots of throughput. The reality is sending a dimming level or a color temperature level or occupancy status or any of the types of things we're talking about in the lighting world, Wi-Fi is just way more complexity and way more overhead than you need for lighting, but it's out there. InOcean, Li-Fi, and Thread are newer ones. InOcean is a very low power protocol. They make a lot of stuff that's compatible with Bluetooth and Zigbee. Li-Fi is basically optical, so it's light-based. So the cool thing about Li-Fi is if you have in-room controls that have line of sight, there's some cool things that happen there. Obviously no interference with RF because it's in the optical space, although you could argue it's still radio frequency, but it's very, 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 very high frequency. Thread is a Google-related solution. Google started it and spun it off. Thread is starting now to get integrated with Zigbee. I'm starting to get a little technical on you, but the cool thing about Thread, if anybody's ever heard of Arrow
or Google Wireless. You can go to Costco and buy those solutions, right? They use Thread to essentially create a mesh network so that devices can talk to each other, not just back from point to multi-point. They can actually, the nodes can talk to each other. That's really the technology that Zigbee and Bluetooth mesh work on, and is how this stuff's going to get really reliable and very scalable and very, very cost effective. In fact, at the end, if we have time, I kind of moved it out. There's a whole wireless section of this presentation that talks about all this, if anybody's interested. So digital versus analog. Remember we talked about 0 to 10 and digital. So let's just say a typical space. This is actually a classroom, but it could be an office, open office space. You have some desks, and in this case, you've got a teacher's desk up front and a whiteboard, and this is all windows. And in this application, you might divide the room up into multiple zones to accomplish these different features. So we have occupancy sensing. That would be, of course, for the whole room. We have a couple of zones of daylighting. Anybody have any idea why we'd have a couple of different zones of daylighting? Yep, yep. And so we would break it into zones because if you look in this room, where is it brighter? Closer to the windows. It's darker, closer to the wall. Well, we have multiple rows of lights. We don't want to just dim all the lights together. We want to dim the lights closer to the window, maybe even all the way to off. The lights in the middle, maybe 50%, and the lights all the way on the other end, maybe you only want to dim them 10%. So what splitting it up allows us to do is to have the light be even across the space because of the natural daylighting coming in.
So if that's done and executed correctly, it's invisible.
Yeah, you don't know. Yeah, correct. The room looks even, and you get the benefit of, number one, the natural light, which is very, very hard to produce with artificial lighting, and also the energy savings, right, of not using artificial light. And then you might want to have personal control, and it's not just personal control from oh, I like it dimmer. It's, I have a projection screen, and I want to be able to dim the lights at the front of the room so the projection screen is better visible. Or in an open office space, I want to be able, you have very common these days, oh, the lights are too bright. Right? Big problem we see in general with LED, especially retrofits in office spaces, is they come through with, they take these standard 2x2 fluorescents and they pop in LEDs. And the problem is that the LED that gets dropped in is 2 to 3 times brighter than the fluorescent ever was, right? And in many cases, you can't even get one that is dim enough. And nobody really thinks, oh gosh, we don't need to put 1-for-1 replacements. And so that's what happens. Or you just get the user that says, I want dimmer light. So to be able to have personal controls is very valuable. So how would you accomplish this solution? Well, with analog, 0 to 10, you have that lighting controller. And you've got to get 0 to 10 low voltage control wiring to each of those zones, right? And that's in addition to power wiring. So if there are 6 zones, there are 6 pairs of control wires that go to each zone. If we do it with digital, you basically have one digital connection that links to all the fixtures. And this connection can be, in many cases, run with electrical wire. So the electricians can literally pull just 2 extra wires along with their power and connect that power and control, that digital control wire, to every single fixture. It doesn't matter how they're zoned, because with digital, now the control system, the smart box, if you will, and these are really not big, complicated systems, can talk to each fixture. But this doesn't work with just any fixture. You have to make sure, back when we were looking at fixture options, that we choose one that is compatible with the digital controls that we're selecting. So in this case, you run a whole bunch of less wiring. You save a lot of electrical cost. You save equipment cost. And now you have the ability in the configuration of the system to determine how we're going to make the system operate, because we didn't wire it. So in this solution, we wired our zones, right? And if you wanted to change how it's zoned, you would literally have to go into the ceiling and change the wiring. In this solution, changing zoning is done in programming. And usually it's very quick and easy to do. So here's another example where you have, in this case, this is a zone of analog dimming. This is a zone of analog dimming. And then each one of these small offices is a zone of analog dimming. So how many different cable runs do you have to have? 1, 2, 3, 4, 5, 6 dedicated pairs of low voltage cable. Whereas in the digital option, it's still just one. Even though there's multiple rooms, it's still only one control wire. So this has been around for 20 years. This really started with compact fluorescent
and is very, very popular with LEDs. Why? Because an LED fixture, and we talked about before, that needs that DC power supply, well, there's smarts in that power supply to make it work. It's a very minor incremental cost to add digital control. And when you add that digital control, you remove the need for all of the equipment in the closet to provide that analog traditional means of control. So in the end, you will save money, but it's about making the right selections up front. So again, this goes back to fixture selection. You've got to pick the right fixtures that are compatible with this. And what we see from an integrator standpoint when we help with design is if we don't get involved early and make sure that it's designed this way, electrical contractors will bid these projects this way. And then we'll redesign it. We'll say, we're going to save you money. We're going to take out all the controls and everything. And by the way, we're going to save you money on the electrical too. No, we're not. Because the electrical contractor already bid it this way. You think he's going to go back and rebid it this way? He's not getting paid to bid it twice, especially when the price is going to go down. So he'll go, oh, yeah, price is the same. So it's really important to ask these questions early, get these decisions made early. And what we tell our clients when we're doing design is we need to make sure that when drawings go out for bid, even 30% drawings for pricing, right, for budgeting, to make sure that these decisions are made and specified. Even if the design's not done, just a big note, controls, this is what it's going to be. Here's essentially a copy and paste simple diagram of this is what all the controls will look like. This is how you're going to run your wiring. It's not every single zone, just this is what it's going to look like. So when we get to 90%, it'll all be detailed, but this is what it's going to be. And we have had multiple projects where we have a conversation with the electrical contractor. We explain how this works because they can be scared of this in the beginning. The bigger firms at this point have used these systems, and you get to the right person, they understand it. And then they go, the light bulb usually goes on, they go, oh my gosh, that makes so much sense. That saves so much labor. That's great. And most electrical contractors you talk to today, they're happy with that because they have so many projects. They want to get in and get out and move on to the next. So the less labor they can spend pulling cable, particularly the low voltage cable, right? The electrical, if it doesn't use a wire nut and it's not an MC or pipe, they really don't want to mess with it. And this greatly simplifies that because they can buy what they call luminaire cable that has the extra control wires built in, or they can run it inside a pipe. It's really easy to run.
So hold on, so Peter just talked about how many advantages to your project that presents. Do you see the advantage for you? Do you know what that major advantage is for you as the lighting designer working with a client? So how many times have I called the architect or the lighting designer or the interiors person and said, hey, are you ready for me to come help you? No, I don't have the zoning from the owner yet. The owner doesn't know how to this zone yet. Guess what? I'll take that away from you. You don't have to know that now.
Yeah.
We can decide that later. So it just makes your productivity basically go because you don't have to wait on that information to complete your job.
So remember in this example, compared to here, so that's all zoned, how we wired it. But because it's one digital communications, we don't have to pick zoning. And the drawings become much simpler because now we don't show, the little pigtails that connect together to all the fixtures, that's indicating zoning. You don't have that in this system. This wire in this diagram is really just indicating for demonstration purposes how the fixtures are connected together for control. Typically on a drawing, what we're going to do is we're just going to show a link, a letter, and a count of how many, because you can put up to 64 fixtures typically on these. DMX will do up to 512, well, that's a little misleading, it's more like 32 on one physical connection. But we typically don't show the link together. They're just devices on a reflected ceiling plan with an indicator that shows a count, and that's it. And the actual functional operation gets decided much, much later.
Peter, something else with that last slide too is if you think of day 2 in the future, if you do reconfigure any of this space at all, or when you're doing it this way, it's a rewire job. With this, it's just a reprogram.
Correct. Yep. Yep. So one more reason not to use 0 to 10, if I haven't given you enough. This is an actual picture of a real space that has tunable white lighting with 0 to 10 control. And there's 2 issues. 0 to 10 is analog. It's literally DC. 0 is minimum, 10 is maximum. Well, you run usually no more than a 14 gauge, but usually it's an 18 or a 20 gauge wire. And you run that 1,000 feet, you will get voltage drop. So if the controller outputs 5 volts for 50%, and you run that wire 1,000 feet over 18 gauge wire, you might get 4.5 volts or 4 volts, which, oh, no big deal, a half a volt, nobody's going to know, right? Well, if your scale is 0 to 10, right, 1 volt is 10% of that total. So in a large area, you will literally see the lights get dimmer as you go further down the line. The other challenge, and this is represented very well here, is when 0 to 10 is used to control color temperature, same thing, right? 0 might be 2200 degrees Kelvin, and 10 might be 6000 degrees Kelvin. As you lower the voltage, the color temperature gets warmer, right? So that's what happens here. The color temperature gets warmer the further down in the room you get. So just another reason why 0 to 10, unless it's one room, one zone, controller on the wall, simple, or a power pack in the ceiling with an aux sensor, fine. But beyond that, stay away from it. It's not a good solution. So one last thing here we'll cover is why would you actually use controls, right? Why wouldn't you just put a switch on the wall? And there's a bunch of reasons, right? So dimming, especially with LED, every LED can dim, right? Anybody that says that, oh, LED is non-dim, like fluorescent, typically was non-dim unless you really made an effort to make it dim. LEDs are inherently dimmable as long as a good quality fixture with the right electronics is selected. The ability to do what we call high-end tuning, or essentially drop down from 100% to 90%. Most people can't see a difference in light output, but you save, it's a linear savings in energy. Obviously, occupancy and vacancy sensing is a huge one, and these days it's a code requirement. Not just for occ and vac, but also probably need to add here, unfortunately, is outlet control, right? I imagine at this point you've probably at least heard of potentially horror stories. The latest one I heard, which I love, is, oh, we're going to solve the 50% controllable outlets problem by just putting in twice as many outlets. That's one way to do it, I guess. And there are creative solutions that we can help with on that. Obviously, I mentioned personal dimming, the ability to adjust lights especially in an open office space. The big advantage there is, yes, it's going to cost money. We see a lot of, especially corporate headquarters, executive office spaces, where the value gained and that extra additional cost over the life of the space to give the knowledge worker the ability to adjust the lights to be more comfortable has a huge payback. Scheduling control is a really big one. Any control system today has the ability to essentially run an astronomical time clock, which basically means it can calculate sunrise and sunset every single day of the year. So you're not setting fixed times, you're not having to update schedules or go to a motor controller and adjust the wheel based on daylight savings or summer versus winter. Integration of motorized window treatments, shades and draperies is a really big one. We see that, especially in executive spaces, conference rooms, collaboration spaces, meeting rooms, where they want to be able to close the outside light when they're doing video conferencing is a big one. Oh, we did add plug load control. I forgot about that. Load shedding, not as big in Florida. When you go to California or the Northeast, that's a really big one. Utilities basically saying, hey, we need to reduce energy consumption. And then, of course, integration, a big thing for us. We talked about HVAC control, AV system control. That really, as we go forward, honestly, I could rename that to smart building integration because that's really where we see it going. So what are the benefits of these different control strategies, right? So, of course, the big one is always energy savings. That one is very dependent, of course, on how the space is used, the type of the lighting that you're controlling, but it can still add up. Of course, reduced operational costs. This is a really big one. Again, if you match beginning and end and you get what is needed, and that's a big thing that we like to do is we want to talk to the end user and understand what they need. The operational savings can be huge. We have a lot of clients that literally tell us that they can reduce staff, headcount, because of systems that are well designed and easy to operate because they just don't require the day-to-day maintenance. Of course, increased comfort. We talked about the example of personal control. There are lots of examples where the right light in the space is valuable. Of course, accuracy and fidelity, a big one there when it comes to LED. We went from incandescent, which was really nice, warm light, to fluorescent, which was really just disgusting light, terrible. I mean, I'm so glad the days of fluorescent are pretty much over. In fact, the DOE created this thing called CRI, Color Rendering Index, maybe you've heard of, right? Pretty popular. Throw it away. I kid you not. You still see CRI related to LED today. it was designed to rate color quality of fluorescent because fluorescent was so bad that the DOE said, hey, we need a way to quantify not just energy savings, but light quality. Problem is that system was based on fluorescent. And lighting manufacturers have just translated it to LED. There's a whole new thing called TM30. If you're interested in it, shoot me an email, call me, I'll send you a link. It's a very interesting thing. But basically, my point in all of that is, right, what's the takeaway? Is that we can now produce light quality that is better than incandescent. Because with incandescent, I couldn't reproduce the wavelength of light that comes from the sun or from being outside, where now with LED we can. So there's all sorts of research enhancements coming. I'm going off on a tangent for a second, sorry. Enhancements and things that you can do in terms of picking specific wavelengths that respond for patients that are recovering, for people that work in facilities where they work at night and they have, I forget what the term is, but, well, circadian rhythm, but there's a specific diagnosis, something effective where, yeah, well, so the blue light, 570 nanometers, I want to say, something in that range, where if you work at the night and your clock is reversed, where sleeping and working in the right color temperature and specifically frequency of light is a big deal. There's a lot of reasons. I don't really get into the details on the yet because nothing's proven. There's a lot of junk science right now for manufacturers, but that's a big one that's coming. My point in all of this is that we're really entering an era with LED where we can produce better light than we could ever artificially produce in the history of artificial lighting. And controls is a big part of that. Anyway, back on track. Contribution to well buildings, right? That's a big one. That's very much affects what I was just talking about. There's a lot happening there and a lot that will happen. Space utilization is actually a big one. So now, once again, once we have controls, what we're talking about there and what we're using today is occupancy sensors that don't just turn the lights on and off, but they report back utilization of a space. So imagine you're doing programming for a new office building or tenant improvements, and they're deciding whether they need 100,000 square feet or 80,000 square feet, whether they need 50 meeting rooms or 20 meeting rooms, or even 5 versus 2, right? Space utilization can help them make decisions based on how much was the space actually used, and where it's going is not just was the room occupied, but how many people were in the room. And with that information, you can start to make smart decisions on design and right-sizing spaces. So as this data collection starts to really happen, another Google term, if you haven't heard it, go search something called big data, right? It affects everything, right? From healthcare to building automation. Where that's important here is as we can collect more data and these systems, the buildings become smarter, then we can use that historical data to make the building and design decisions. So we do a lot of work up in the Northeast and college campuses, and MIT is one of our largest clients up there. And they are actively working with us on pulling data from the buildings that have this capability in their spaces, and they literally they have this data. Now, there's 120 buildings on campus. There are 14 buildings that have this type of system, and of those 14 buildings, maybe 20% of the actual space in the building has this data collection capability. So it's relatively small, but they can at least use it as a sample for how are we utilizing our spaces. I can guarantee you lighting will be at the core of collecting this data moving forward because, again, lighting is where people are, and the technology is now in the ceiling to control the light. Well, now it's going to be able to tell not just that somebody's in the room, but how many people are in the room. You heard me talk about asset tracking, and I've mentioned integration multiple times. So that is the presentation. Questions?